Okay, so in this video, we continue with question number 10. Okay, they give you a circuit. They ask you to find the equivalent capacitance and then determine the charge on 3 and 5 microfarad capacitor. So the first thing that you can do is that you can determine which one is series and which one is parallel. Okay, so you can see a junction over here. Maybe I can label it as well, C1, C2. Oops. This is my C3 and this is my C4. Okay, so if you identify the junction, so you can see that C2 and C3 is in parallel to each other. Okay, and then you can see there's another junction which is over here, which shows that this one C4 is parallel with whatever over here. Okay, so I can try to redraw this into a simpler form. Okay, if you get questions like this, try to redraw step by step. Okay, so this is my dry cell. Oops. Mm. Which is 10 volt. Okay, and the junction over here, okay, maybe I can draw it like this. And junction, and then that particular C4, then close the junction. This is my C4. Okay, so I'm actually drawing over here. So this is the junction, the blue one, and then they split up into two. One goes to C4, which is this one. Another one goes to C1, which is that one. So, okay. After that, it meets another junction over here. This is my C1. At that particular junction, it's split up into two, which is C2 and C3. Close the junction. That end up like that. Okay, so basically it's still the same numbers of capacitor. I just try to redraw it so that you can see clearly which one is in parallel and which one is in series. So C2 and C3 are in parallel, so I can combine those two. Okay, so this is step 1. Okay, if you solve that one, then you can get something like this. Okay, you really need to spend some time to redraw all these things. Okay. Okay, this one would be C4. This is still my 10. Oops. This is still my 10 volt. This is my C1, and this is basically my C23. So I already combine it. First you have to combine C23, and then you will end up with something like this. And the junction remains the blue junction there. Okay, the next one will obviously solving C1 and C23. So this is your step 2. Okay, if you solve this one, so I'm running out of page, so I just draw it down there. So you're left with something like this. Okay, so this one will be C123. This would be your C4, and this would be your 10 volt dry cell. And the last step, obviously, you just have to combine C123 with C4. Okay, so that's how you can calculate the C effective. So we start with the first one to find C23. So C2 and C3 are in parallel. So to solve that one is C23 equals to C2 plus C3, which is equals to 5 plus 6 microfarad. So for this one, you end up with 6 plus 5, which is 11 times 10 negative 6 farad. Okay. And then obviously the next step, you can do the step number 2. This step 1. Okay, step 2, basically this one. So you want to solve C1 and C23. Okay, C1 and C23 are in series. So the equivalent capacitance or the effective resistance, effective capacitance will be 1 over C123 equals to 1 over C1 plus 1 over C23. Your C1 is equivalent to 2 microfarad. So 1 over 2 times 10 negative 6 plus 1 over 11 times 10 negative 6, 1 over C123. Then you press your calculator. So here I got 1.69. Okay. Times 76. Okay. C123 is equals to 1.69 times 10 negative 6 farad. And then the third step, which is this one, basically C123 and C24 is in parallel. So C1234, which is basically your C effective, because there's no more capacitance. C123 plus C4, 1.69 times 10 negative 6. Your C4 is equals to 3. So C1234 is equivalent to 4.69 times 10 negative 6 farad. So that one to answer question A. Okay. For question B, they ask you to find the charge on 3 and 5. So 3 would be over here and 5 would be over there. So basically at C4 and C2. So they want you to find Q4 and Q2. Okay, we can start with question Q4 first. So from here, okay, one of the key things that you can see straight away is that the potential across here is equal to potential across there and there. So basically, V terminal is equals to V4, which is across the capacitor 4, and equals to V123, okay, which is equals to 10, I think, yeah. So if you use C equals to Q over V, if I want to find Q4, I have to substitute V4 and C4. So my Q4 is equivalent to C4 times V4. Okay, C4 is equal to 3. V4 is equal to 10. So you have 30 micro. This is charge, so will be coulomb. And then the next one, you want to find Q2. Right. So you already found Q4 over here. So this one you already have the value. And then the next step, obviously, you want to find the Q2 over here. Okay, if you know the values for Q4, then I can know the values of charge going over there. Right. So the charge coming in is my Q total. And then it becomes split up, becomes Q4 and whatever that is. So let's put this one as Q23. So Q23 and Q1 will be the same, but there's no junction over here. But the key thing is over here. You have a junction. So you have to find Q total first. Okay, Q4 you already found. And then Q total minus this one, you will get the remaining one that goes over there. Then only you can solve over here. We solve this one first, okay? Okay, now if I want to find my Q total using the same formula above, let's say I put this one as B1, B2. Maybe I do different page. Okay, so your Q total is equals to C total V total. So basically I use C equals to Q over V lah. I rearrange. And then my C total here is basically my C effective. That one's V terminal. So C effective is equals to 4.69 times 10 negative 6 multiply with V terminal, which is 10. I can get Q total. So 46.9 times 10 negative 6 coulomb. Okay. So to find Q23 like I did before, it is Q total minus Q4 because of the junction there. So this one becomes 46.9 minus 30 times 10 negative 6. 16.9 times 10 negative 6 coulomb. Okay, so that one is the charge that goes over here. Is it? This is the diagram. Okay, so if I can find my potential over here, because the potential over here and potential over there is the same, then I can use C equals to Q over V. So I can use C2, V2, and then I can find my Q2. Okay, so I think I'm going to copy it over here, copy everything. Okay, maybe I copy this one first. Okay, copy everything, bring it down over here. Okay, so we already found the Q23 here. Okay, so the same Q23 we pass through over here. Okay, I can solve straight away. C23 equals to Q23 over V23. Find my V23 first. Okay, and once I found my V23, which is equivalent to this voltage over here, then I can solve the C2 problem. Okay, so V23 is equals to Q23 over C23. Q23 16.9. Okay, and C23 we already calculated that one. C23 by C23. 11 times 10 negative 6. Okay, so 16.9 divided by 11, 1.54. Okay, and this one is equals to V2 and equals to V3. Okay, so basically this one is equal to that one and that one. So to solve V23, sorry, I want to find V2 I want to find Q2. So C2 equals to Q2 over V2. For my Q2 is equals to C2 V2. C2 is equals to, okay, a long way from the question, 5 microfarad times 1.54. So this one, even though the question seems like a simple one, but the workings takes a little bit time. So as long as you draw step by step, and then you solve it one by one, you shouldn't have a problem. Just have to go back one by one. Because here is 7.7 times 10 negative 6. And then maybe if you want to make things easier for the pemeriksa, you can list down the values that they ask, which is Q2 and Q4. So therefore, Q2 is equal to 7.7 times 10 negative 6. And Q4 just now we got 30 times 10 negative 6.